Okay, so suppose you want to study this limit as xy goes to 0, 0 in problem number 20. Part A says go along the path y is equal to mx, where m is a non-zero constant here. So what that means is we should substitute in everywhere we see a y, replace it with mx, x squared times mx over x to the fourth plus 5 times mx quantity squared. This is the thing we're taking the limit of. Limit as x goes to 0. I don't have to write xy goes to 0, so I can just write this as limit as x goes to 0 because there's only x here. Okay, let's try to simplify this. Factor out an x if possible, or powers of x if possible. This is m times x cubed over x to the fourth plus 5m squared x squared. We can factor an x squared out of the denominator. X squared times mx. We can factor x squared out of both the numerator and the denominator. So x downstairs will be x to the fourth becomes x squared times x squared. 5m squared x squared becomes 5m squared times that. Okay, so our x squares cancel out here. So the limit is x goes to 0 of mx over x squared plus 5m squared. Okay, so remember we were told that m is a non-zero constant here. The limit of this as x goes to 0 is going to be, we can evaluate this just by substitution. It's going to be m times 0 over 0 squared plus 5m squared. And this is 0 over something that's not 0. 5m squared, m is not 0, so the denominator is not 0. So this is not the indeterminate form. This is literally 0. So if you go to 0, 0 along any straight line path y is equal to mx, where m is not 0, the limit is going to be 0. Now, however, part B says, well, what happens if you go along y is equal to bx squared? If you go along y is equal to bx squared, the limit is x goes to 0. I'm going to copy this, but everywhere I see a y, I'm going to put bx squared. X squared times bx squared over x to the fourth plus 5 times bx squared squared. Okay, simplifying this, upstairs we have bx to the fourth. Downstairs we have x to the fourth plus 5b squared x to the fourth. It looks like we can factor out an x to the fourth, both the numerator and the denominator. And we're just left with limit as x goes to 0 of b over 1 plus 5b squared. There's no x dependence here. The answer is just b over 1 plus 5b squared. And then part B is actually asking us, what are the values of b for which the limit along this path gives us 1 over 6. So need to solve this equation here. Cross multiplying, let's see here, 6b is equal to 1 plus 5b squared. Moving everything to one side, 5b squared minus 6b plus 1 is equal to 0. And I assume this factors rather easily. I'm just going to go ahead and quadratic formula. So b is going to equal to negative b. Okay, so that's 6 plus or minus square root of 36 minus 4 times this, so that's going to be 4 times 5 is 20 all of that over 2 times a, all that over 10. 6 plus or minus square root of 16 is 4, all over 10. So it looks like we get 2 solutions here. It looks like we get 6 plus 4 over 10, b is 1. 6 minus 4 is 2 over 10, b is 1/5. So 2 values of b, I botched this up, and give you 1/6. But then part C says, given the previous 2 parts, what can we conclude about the limit as x, y goes to 0, 0? What can we conclude about this? We can, of course, conclude that this does not exist. Why? Because if we go along any straight line path of the form y is equal to mx, m is not 0, we get 0. But if we go along y is equal to 1 times x squared, for instance, we get 1/6 as our limit. To path tests, we have 2 different paths that the limits along those paths give us different numbers, 0 and 1/6. We can stop there and say the overall limit does not exist.